So let's look at this question again. So notice this one, we don't have anything that we can pull out, right? What's the GCF between x squared and 9?
1.
Right, you could pull out a 1, but that's not going to help you because you're going to end up with the same thing, yeah?
Mm-hmm.
If you were to pull out a 1, you get 1 and then x squared minus 9. So we have actually not factored this at all. So when you see something like this, there's other tricks that you need to use. And for this question, there's something that's called a difference of squares. Now, what is this? So if you have something in this form, a squared minus b squared, okay? And they're completely independent, different terms. You can't pull anything out. But if it's in this form, you can rewrite this as a minus b times a plus b, okay?
Okay.
Compare this with this, a squared minus b squared. What is a and what is b?
A is x.
Yeah, what about b?
9.
No, that's b squared.
Oh.
B squared is 9, what is b?
3.
Yes. Like that.
Okay.
So now we can rewrite this as what? A, or sorry, not a. We know what a is. A is x. So we can rewrite this as x minus 3 times x plus 3. Okay?
Mm-hmm.
And just like that. Let's try another one. What about for this? What is a and what is b?
A is x.
Yeah?
And B is 8.
Right. B is 8. So you have x minus 8 times x plus 8, and you're done.
Okay.
Look at the pattern. You can only use this if you have something squared minus something squared, okay? Like if you have something like x squared minus 3. Now this is squared, but this, you can't really square root this, right? It's a prime number. So this, you can't use this formula. Both of them needs to be a squared. But it does get a little bit dicey. Let's try this one. What about here? What is a and what is b?
A is 4x.
No, that's a squared. A squared is 4x squared. To find a, you need to square root both sides. A is going to be the square root of 4x squared. You can do them individually. Square root of 4 is 2. Square root of x squared is x. So a is actually 2x. What is b?
5.
Right, and then you can write this as 2x minus 5 times 2x plus 5.
Okay.
Same idea here. What is a? And it's not 16x.
Is it 4x?
Yes, it is 4x. What about b?
9.
Yeah, so you have 4x here and 9 here, and you can rewrite this as a minus b times a plus b. You can also write it as a plus b. It doesn't make a difference. Like you can write a plus b first, and then you can write a minus b second. The order doesn't matter. Only a and b, what they are matters. And the sign has to be different in the middle. What about this?
You can't really square it, like.
Yes, you can. 1 squared is 1.
Oh. So 8x and then 1?
Yeah, exactly. A is 8x and b is 1. So 8x minus 1 times 8x plus 1. Because if b squared is 1, b is still 1, right? If you square root of
Mhm.
both sides, b is still 1. So 8x minus 1, 8x plus 1. Here's a better question. What if I were to, instead of 64x squared, I did 64x to the power of 4 minus 1? Now what is a? B is still 1, but what is a?
Um,
So you get something like this. The square root of 64x squared, sorry, x to the power of 4. Square root of 64 is 8. What's the square root of x to the power of 4?
x to the power of 2.
Yeah, that's exactly what it is. So this one, we can rewrite this as 8x squared minus 1 times 8x squared plus 1. What's the square root of x to the power of 10?
To the power of 5.
Yeah, you just chop the power in half.
Mm-hmm.
So that's a difference of squares, okay? Notice it'll only have two terms, a squared minus b squared. And this is a trick that you can use. What about this one?
You can't really.
Yeah, you can't do that just yet though, but you can pull something out.
5.
Yeah. If you pull out a 5, what are you left with?
Um, 10x.
10x squared.
And then 1.
Yeah, minus 1. Right?
Mm-hmm.
And you're done, because you can't really square root 10x squared. It's not a nice number. What about this? Now there's 3 terms here, so this is not a difference of squares, that's for sure.
What are we supposed to do for this one?
I'll just pull out whatever they all have in common.
Is it 6?
Yeah. And what are you left with?
X to the power of 2.
Mhm.
Minus 3x.
Yeah. That's the last term.
Plus 4.
Yeah. And you're done. Okay.
Okay.
Easy as that. What about this one?
Nine x and 5.
Yeah. So you got 9x minus 5 times 9x plus 5. Okay.
Mm-hmm.
What about here?
Not sure.
What do they all have in common? Can you pull anything out?
Just one?
No, x,
Oh,
right? They all have an x. If you pull out an x, what are you left with?
three to the power of two.
Yeah, 3x to the power of 2 minus 2x plus 1.
Okay.
And you're done for this one anyways. All right, now we're gonna do something different. I mean, we're not gonna do, it's not gonna be completely different, but there's a new trick in the book. Look at this question. Can we use difference of squares for this? Notice this, number one, they have nothing in common, right? You can't really GCF out anything. So the next thing you want to look at is, can you do a difference of squares? No, you can't, because difference of squares requires a minus sign and only two terms. Two terms that you can square root anyways. So you can't do that here either. So if you get something like this, what do you do? So this is what you call, look at this, there's three terms, 1, 2, 3. This is called a trinomial.
Mm-hmm.
A trinomial. And what's the power? It's 2, right?
Mm-hmm.
So this is called a power 2, means instead of linear, it's called quadratic. That's the name of it. So quadratic trinomial. And you can't really GCF out anything here. So what can we do? Now the trick is this. We are gonna use a method called the man method. Now what is this and how does it work? You are looking for two numbers, okay? The numbers will be the same. When you multiply those two numbers, you get a 12. When you multiply them, you get a 12. When you add them, you get a 7. What are those numbers?
3 and 4.
Yeah, 3 and 4. And once you have these, what you want to do is you want to break down the middle guy here, 7x, into those two. So 7x, we're going to rewrite it as 3x plus 4x plus 12. And now we are going to factor two terms at a time. Look at this. From the first two terms, what do they both have in common? What can we pull out?
X.
Yeah. And you're left with x plus 3 in the bracket. From the next two terms, what do they both have in common?
2.
No. GCF. So they do have two, but you want to pull out the biggest thing if you can.
4.
Yeah. And what are you left with?
X and 3.
Right, x plus 3. Now what we're going to do is we're going to pull out this bracket. Look at this. If you have x times a plus 4 times a, if you pull out an a, what are you left with? They both have an a, right? So we can pull that out. You're left with x plus 4. Same idea here. Treat this bracket as an a, okay? We're going to pull out the whole bracket, x plus 3, because they both have that in common. What are we left with?
I'm a little confused.
You're left with x plus 3. Oh, sorry, x plus 4. Just like this one.
Okay.
See if that made sense. We're pulling out the a, right? The a in this case is our bracket. Now we're left with whatever we didn't pull out, x plus 4. Same thing here. We're pulling out the x plus 3s, and we're left with x plus 4 in another bracket.
Okay.
and you're done.
Mhm.
Same idea here. We are looking for two numbers. When you multiply them, you get the last guy. So in this case, it's minus 12. When you add them up, you get the middle guy, minus 1. What are the two numbers?
Minus 12 and 1.
No, that's not going to add up to
Oh.
minus 1. -4 and +3.
Oh, okay.
Right, when you multiply them, you get -12. When you add them, you get -1. And once you have those guys, you want to break down the middle guy, the one with an x on it, into those two. So you get x squared minus 4x plus 3x minus 12. From here, you group them two at a time. From the first two, what can we pull out?
Just x.
Right. What are you left with in the bracket?
X and 4.
Yeah, x minus 4. What about the next two?
3.
Yes. And what are you left with in the bracket?
X and minus 4.
So notice these brackets will always be the same. As long as this is right, as long as this works, those two brackets should always be the same. Now we're going to pull out that bracket because they both have that bracket in common, x minus 4. And in the other bracket, we're going to throw in whatever is left over, x plus 3, x plus 3. Okay?
Okay.
Let's see if there's a dicier one. All of these are pretty straightforward. Okay. Same question, or look, because again, you can't pull anything out. We're looking for two numbers. So what do they multiply to?
30.
Yeah. What do they add up to?
13.
Minus 13. The sign is significant. So what are the two numbers?
Minus 10 and minus 3.
Yeah, good. Minus 10 and minus 3. Now we're going to rewrite the middle guy as x squared minus 3x minus 10x plus 30. From the first two, we can pull out an x. We're left with x minus 3. From the next two, what can we pull out?
10.
Minus 10. What's left?
X plus 3.
No, we pulled out a minus 10.
So x minus 3.
X minus 3. Now why did we pull out a minus? Because we need these two brackets to be the same. And whatever the sign is here for the next term, you want to pull that out. And then you're left with x minus 3 times x minus 10, and you're done.
Okay.
All right. Now for this one, you see it's a mix, so you may have to use multiple strategies. What do we do here?
You can't pull out anything.
That's right. So what do we do in that case?
The MAN thing.
So I didn't tell you this. When you're doing when you multiply them, right, the numbers that you're looking for, the add is gonna be the middle guy, 7. But when you multiply them, it's actually gonna be this, whatever the coefficient of x squared is, times the y-intercept. So when you
Okay.
multiply, you're actually looking for positive 12 because -1 times -12. Okay, not just -12. The sign, but we didn't have any numbers up until now in front of x squared, but now we do. So that number is also significant. So basically, you have to look at all 3 coefficients of the terms. So what are the 2 numbers that satisfy these conditions?
3 and 4.
Yeah. And then we're gonna do the same thing we've been doing all day long. We're gonna break down the 7x into 3x plus 4x minus 12. From the first 2, what can we pull out? And again, the sign is significant. So they both have an x in common, but this one has a minus x squared. So you're gonna pull out a minus x. What are we left with in the bracket?
X plus 3.
No, we pull out a minus x.
So minus x plus 3.
Yes, minus x. No, it's gonna be x minus 3. Look at this.
Oh,
Minus x squared over minus x. What does that give? The minus signs cancel out. It just gives you an x, okay? And 3x over minus x, the x's cancel out. You're left with 3 over minus 1, which is minus 3. Like that.
Okay.
Now from the next 2 terms, what can we pull out?
4.
Yeah, plus 4. What are we left with in the bracket?
X minus 3.
And then what's the last step?
You have to take the things outside of the bracket.
Yeah. So we're going to pull out the bracket x minus 3, and then in the other bracket, we're just going to have whatever's left over. Like that, and we're done.
Okay.
What about this?
Can you just pull out 3?
Yeah. And you're left with x squared minus 1, right? Now, can you factor this?
No.
Oh, yes, you can. It's a difference of squares. Right? Because a squared is x squared, a is x, b squared is 1, b is 1.
Oh, okay.
Then you have 3, and then you can use a minus b, a plus b. So x minus 1 times x plus 1. Okay?
Okay.
This one might be a little bit tricky. What did they both have in common?
I don't know, 2.
Not a 2. So you want to do the guess and check, right? What goes into 32? Again, ideally you want to pull out the biggest thing that you can. In this case, it's going to be an 8. So what I did was I checked if 32 goes into 200, it does not. Then I checked half of this. 16 goes into 200, it does not. And then I checked for 8, half of that. So 32, 16, and then finally 8. And 8 does go into this. So the biggest thing you can pull out is an 8 here.
Okay.
Pull out an 8. What am I left with in the bracket?
4x
Yeah, 4x squared.
minus 25.
Yeah. Now look at the inside bit. Can we factor that?
No.
Yes, you can. What's the difference of squares in the bracket? No. A squared is 4x squared. B squared is 25. What is A?
2x
Yeah.
squared.
No, just 2x.
Oh, okay.
Right, you want to cut the exponent in half. So right here we have a 2. That means when you square root it, it's going to become a 1. And on the other side, we get a 5. You see? We can rewrite it as a difference of squares. So what's the last step here?
Um, 2x minus 5 and then 2x plus 5.
All right, 2x minus 5 and 2x plus 5. And you are done.
Okay.
Let's try this one. How do we factor this?
You can pull out 5.
Yeah. And then you're left with x squared plus 2x plus 1. Now you got to check if you can further factor this or take it one more level.
I don't think so.
So you want to check, right? What do they multiply to? They're looking for 2 numbers. They're going to multiply to, again, this one doesn't have a number in front of it. They multiply to 1 and add to 2. Do they exist?
Is it -2 and -1?
So that's not going to add up to 2. It's 1 and 1.
Oh,
Okay, that's 1 and 1. So we're going to leave the 5 on the outside, and we're going to rewrite this as x squared plus x, or 1x, plus another x, because 1, and then plus 1.
okay.
Cool?
Mhm.
And then from the first 2, we can pull out an x. We're left with x plus 1. And from the next 2, they don't have anything in common, but we can pull out a 1, because the goal is to have the same bracket. These 2 brackets have to be the same in order to use this man method. So here, even though they had nothing in common, I pulled out a 1 because I wanted this bracket to be the same thing as this bracket, so that I can pull out that bracket So you get 5 times x plus 1 times x plus 1. And there you go. That's the final answer for this one.
Yeah.
All right. So now they've already factored it for us. Okay. Now what's the point of factoring this? So we're doing quadratics, right? Quadratics. So it looks something like this, like a U. But it doesn't necessarily have to go through the origin. It can go through anywhere and can even be upside down. Let's look at the key features of a quadratic. So see, this is the x-axis. Wherever a graph touches the x-axis, that's called the x-intercepts, right? Same thing as linear functions. If it touches the x-axis, it's called the x-intercept. And there's going to be 2 of them for a quadratic. And if it touches the y-axis, what is this point called?
The vertex?
No, the y-intercept.
Oh.
Okay, when it touches the y-axis, it's a y-intercept. The vertex is the pointiest part of the graph. Maybe somewhere there, okay, somewhere there. Now, if you factored out a quadratic, see, this is what we're doing all day. We can find the zeros. By zeros, they just mean the x-intercept, okay? By zeros, they just mean the x-intercept. You just change the signs. Look at this. What do I mean by that? X minus 2 times x minus 5, okay? So the zeros of this is gonna be at x equals 2 and at x equals 5. What we're basically doing is we're setting the y as 0. We are doing x minus 2 is equals to 0 and x minus 5 is equals to 0. And this gives you add 2 on both sides, x is 2 and x is 5. So for this quadratic, it goes through 2 and 5. We don't know where the y-intercept is, we don't know where the vertex is, but we do know that it's gonna go through 2 on the x-axis first, and then it's gonna loop back and go out through the 5.
Okay.
Look at the second one. Where are its zeros? For B. Now you just flip the signs, right? Look at this. It's gonna be at 7, because minus 7 becomes positive 7, and plus 1 becomes minus 1.
Oh, okay.
Just flip-flop. Look at C. C is a little bit tricky. So we know one of them is at 10, right? What about the other one? There's always gonna be 2. Not always, but there's 2 here. The other one, you just want to set them equal to 0. Okay, that's how we got 10. We just said x minus 10 equals 0. Add 10 on both sides, we get x is 10. And then you can also set the other guy equal to 0. And that's where the x-intercept is. One of them. The other one is at 10. So it looks something like this. It's going to go through 0. It's going to come down through 0. And then it's going to loop back out through 10. There you go. Okay?
Okay.
You just flip the signs, or if you can't, you just set them equal to 0. Like, it's not always going to be that easy, though. Look at this. 2x minus 5 over 3 minus x. Or are this things x-intercepts or zeros? Same thing. So for this one, you may want to individually set them equal to 0. How do we solve this equation for x?
Add 5.
Yeah, and then?
Divide by 2.
Right, so x is equals to 5 over 2. What about the next one?
You subtract 3.
Right, so minus x is equals to minus 3, and then? You can either multiply by -1 on both sides or divide by -1 on both sides to kill the minus sign.
Divide.
Yeah, no, you can do either. You can do either. So you get x is equals to +3. There you go. So the x-intercepts are at +3 and 5/2.
Okay.
Okay, so it's not always gonna be like x minus 2, x plus 3. This one is simple, right? It's gonna be at x equals +2 and at x equals -3. This one you can just see it by observation. But these ones, sometimes you may have to individually set them equal to 0 to see what it actually is. It's not 5 for this one. Very common mistake. People say it's +5. No, it's not. It's 5/2.
Mhm.
The 2 in the front is significant. Okay?
Okay.
So this one, it's asking us to write it in factored form. So basically, we need to factor all of these. Let's look at the first one. That's a quadratic trinomial. How do we do A?
Um. Do you have to do the man thing?
Yeah. So we're looking for two numbers. What do they multiply to? What do they add up to?
They multiply to 9.
Yeah.
And add up to -10.
All right. So what are the numbers?
Um. Is it just -9 and -1?
Yeah, that's exactly what it is. -9.
Oh, okay.
And then we're going to rewrite this as x² minus x minus 9x plus 9. From the first two, what can we pull out?
X.
Yeah. What are we left with in the bracket?
Um. X minus 0.
No, x minus 1.
Oh, okay.
Okay, and then from the next two, you want to pull out what?
9.
Minus 9. You always want to pull out whatever this sign is, okay? Look at this.
Mhm.
If you pull out a +9, you'll get minus x minus 1, which is not the same thing as this bracket.
Mhm.
So you want to ideally pull out a -9. You're left with x minus 1.
Mhm.
And that gives you x minus 9 times x minus 1. There we go. We factor this. Where are the zeros? By zeros, it means x-intercepts. Any ideas? You just flip it, right? You just flip the signs. It's at 9 and 1. Minus 9 becomes +9 and -1 becomes +1. Okay, do you understand that? To find the zeros, once you've factored it, you just flip the signs. Or if it's a difficult expression, you want to set it equal to 0 and solve for x. But here we can just flip it because it's a simple x minus something.
Okay.
Let's look at the next one. X² minus 4. What do we do there?
Um. How would you do the MAN thing for this one?
No, you don't do MAN for this. MAN is strictly for 3 terms. It's for a trinomial. MAN is strictly for a trinomial. B and C are both difference of squares. Because there's only 2 terms and there's a minus, and we can square root both of them. B and C are both difference of squares.
So x minus 2?
Yeah. And then what's the other one?
X plus 2?
Right. So where are the x-intercepts now that we've factored it?
2 and minus 2?
Yeah. And x equals 2 and x equals minus 2. Okay.
Mm-hmm.
Let's look at C. How do we factor this one? Now this is neither man nor difference of squares. What can we pull out?
X.
Yeah, what are we left with?
X minus 9?
Yeah. So where are the zeros? Are the x-intercepts?
Is it 1 and 9?
0 and 9.
Oh, okay.
So at x equals 0 and x equals 9.
Mm-hmm.
Okay. Now what if they flip the script? So instead of giving us an equation and asking us to find the zeros, in both of these questions, they're gonna give us the zeros to start off with. Look at this. This one has 0 at 3 and at -1, right? So any ideas on how we could work backwards? It's pretty simple. It's going to be something like this. Y equals, again, you see -1 here becomes a +1 in the equation, right? The +3 here becomes a -3. And there you go.
Okay.
But we're not quite done yet because there could potentially be an a value in the front. Just like how we would do for linear functions. How did you find the y-intercept for linear functions? If you remember, if they've given you a point.
You would just plug it in.
Yeah, exactly. So we can't plug the points. We have already used -1 and -3. We can't use those points. We can use any other point though. We can use this point right here. What is that point as a coordinate?
-3.
So it is at 0 and -3. Okay,
Mm-hmm.
0 and -3. So y is -3 when the x value is 0. So 0 plus 1 times 0 minus 3. So you get a times 1 times -3 equals -3. Then you can divide both sides by -3. What do you get as a?
-1.
+1.
Oh, okay.
They're dividing by -3 over -3 is a 1. So there you go. The a value is a 1, and that's the equation. Okay.
Okay.
Tell me, how do we start off with this one? For part B, it has intercepts at 4 and 6.
So x minus 4 and then x minus 6.
Right, x minus 4 and x minus 6. Now, how do we solve for the a value?
You find another point.
Yeah, so what's a point here? Look at the vertex.
1 and 5.
It's always x comma y, okay?
Oh,
X
okay.
comma y. So it's at 5 and 1. That
Mhm.
point right there is 5 and 1. So we want to plug the y value as 1. That's going to give us an x value of 5, like that. Okay?
Mhm.
So you get a times 1 times -1 equals 1. So what does this mean for a?
It's 1.
-1.
Mhm.
So therefore the equation of this one, and we know a should have been negative because it's upside down. There you
Mhm.
go. That's the final answer for this.
Okay.
The equation is this. It wants us to find the x-intercept. So that means we need to factor this. How do we factor this equation? Any
Mm,
ideas?
an.
So here, yeah, we could do that, but look at this. 36 times 4 is a pretty big number. It's 144. If you can GCF out in the first step, do that before manning it, because it will make your life easier. Here, they all have a 4 in common, right?
Mhm.
So you're left with x squared minus 6x plus 9. There you go. Manning 9 and 6 or minus 6 is much easier than manning what's 36 times 4, 144, and adds to negative, because this one has way many possibilities.
Uh-huh.
So if you can GCF out something, that'll be more efficient. So we're looking for two numbers. When you multiply them, you get 9. When you add them, you get minus 6. What are the two numbers?
-3, -3.
Yes, -3 and -3. Okay, so you get 4. And again, the outside part doesn't change. We're going to rewrite the inside as x squared minus 3x minus 3x plus 9. Now from the first two terms, what can we pull out?
X.
Yeah, and what are you left with in the bracket?
X minus 3.
Right. From the next two terms, what can we pull out?
3.
Minus 3. What are we left with in the bracket?
X and minus 3.
Yeah, x minus 3, like that. Okay, then
Mhm.
we get 4x minus 3 times x minus 3. There you go. That's the factored form. Now, where are the x-intercepts?
It's just 3 and 3.
All right, so it only has 1, right? It's at 3.
Mhm.
So now what does that mean? So how does that even work? Because we know there's an x-intercept, but it's only at 3. Usually we go from somewhere and we come back, right?
Mhm.
How do you think this is going to work or look graphically?
Um. I'm not really sure.
It's going to look like this. Its vertex will be at the x-intercept.
Oh, okay.
Okay, because it can't really cross it. If it crosses it, that means we're going to get two different x-intercepts, and we know that's not the case here. There's
Mhm.
strictly one x-intercept, so that means at that point it's going to have its vertex. Okay,
Okay.
the x-intercept is 3. How the graphs show this, it's going to be its vertex. Still a word problem. So this is there's a fireworks, and this equation models it. On the y-axis we have height, on the x-axis we have time. Okay, probably looks something like this. Now, how do I know it's upside down? Because the a value here is negative.
Mhm.
What is the question asking us? When will the rocket hit the ground? So what does that mean?
Like how many seconds it'll take?
Yeah, it's asking us for the x-intercept.
Mm-hmm.
Okay,
Mm-hmm.
so right there. So how do you find the x-intercept of this equation? We need to factor it, right? X-intercepts is when you factor them. What can we pull out?
T.
Right, and what are we left with in the bracket if we pull out a t?
Negative 4.9 T
Yeah, and?
plus 44.1.
Yeah, good. So now where are the x-intercepts for this question, for this expression? Or how do we find them if it's not visible?
Do you flip it?
Well, you want to set them individually equals to 0, okay? This is a little bit complicated. So t equals to 0 is one of the x-intercepts. Well, we already knew that, but that doesn't help us. It's the other one that's the answer. So you want to set that equal to 0. Like that. How do you solve that expression for t?
You subtract 44.
Yeah, you subtract 44.1.
And then you divide.
Yeah, divide by minus 4.9. So 44.1. 44.1 divided by negative 4.9. That gives us what? 9, exactly 9. So t equals 9 seconds. And there you go, that's the answer. The x-intercept is 9. So after 9 seconds, it's going to hit the ground. Look at 2. It's asking us to find the zeros. So that means we need to factor it, right? How do you factor something like this?
MAN.
Right. But see, there's decimals, so it's a little bit complicated than that. So if you can pull something out, do that, okay? To make your life easier.
What can you pull out?
A minus 0.2.
Oh, okay.
So if you pull out a negative 0.2, right? Because we can't man it right now because it's going to multiply to like a decimal, and that's not going to work for us. So if you pull out a negative 0.2, you want to divide everything by negative 0.2. So 3.2 divided by negative 0.2. That's minus 16x. And then minus 5.6 divided by minus 0.2. That is plus 28. There we go.
Mhm.
And this is much easier to man than the decimals. The decimals are impossible. So we're looking for two numbers that multiplies to 28 and adds to minus 16. It is minus 14 and minus 2.
Mhm.
And if you factor it, you'll get something like this: x minus 14 and x minus 2. So the x-intercepts are at 14 and at 2. And there we go. This one we can just flip it because it's a simple expression.
Okay.
Does that make sense?
Mhm.
All right, let's call it a day here for today.
All right. Thank you.
See you next time.